Hello everyone again and welcome to machine learning tips. I know I've made some a while posting videos. I wanted us to actually digest the first lab I posted on supervised learning based on the linear regression. So today we are going to be continuing with supervised learning, but we are going to be looking at what classification with logistic regression. Logistic regression is a base model. As I did mention, I want us to start with the base model, understand how they work before we can go to non-linear techniques like decision trees, random forest, the extreme gradient boosting algorithm, and the support vector machines and so on. So as a recap, we already know that supervised learning is a type of machine learning technique where the model learns from the label data. So which simply means that each training example consists of an input vector and some corresponding label or output. So the goal here actually is to learn a mapping function, f of x, that will map to that output. Recap the two main types. We have regression, which we have seen a base example with the linear regression, and then today we are going to be looking classification where we are predicting what discrete labels. So these discrete labels, since we are starting with logistic regression, will be what we call a binary class problem, which will be what a good example is predicting whether an email is spam or not, or predicting whether a particular message is spam or non-spam. So as I did mention, the first base technique here is we will be starting with is what logistic regression. Just as the name suggests, it suggests similar to linear regression, but here it also makes that assumption that there's a linear relationship between those inputs and the corresponding output. But here, logistic regression is being used to solve what classification-based problems, where we are looking at whether an email is spam or non-spam. It could also be looking at whether a transaction is fraudulent or non-fraudulent. It can also be used to solve problems like for intrusion detection and so on. So the main function here, or maybe the hypothesis function that we are going to be looking at, is to computing that linear combination of what the input futures. So they seem like the linear regression we saw in the previous lessons. So we are trying to learn some parameters WT, which if we want to use our notion on a linear algebra, we can expand this. It will be same like what we have, like the beta 0 plus beta 1 x1 plus beta 2 x2. So here we have changed that parameter a lot. Most of the time we call it the weight, which it could be what w0 plus x0 plus w1 x1 and so on. So here we know that b here is what we call what the bias. So what this hypothesis function is trying to do is to map to a probability where we use what we call what the sigmoid function. For most of us that have taken classes in maths pretty well, we have seen this function, this sigmoid function, which is like 1 over 1 plus e to the minus z, where z here is actually what this linear combination that we are trying to learn these parameters. Now, most of the times in some textbooks, you won't see this 1 plus 1 plus 1 1 over 1 plus e to the minus z. You are going to see something like e to the z over 1 plus e to the z, because if you are trying to use some base knowledge in mathematics, it will simplify to what I just mentioned. So h of t of x is the predicted probability where we are looking at the probability where y is equals to 1 given some input. We are going to see, we already saw the notion of probability, saying that if I want to find the probability, if I roll a die, what is the probability that I'm going to obtain even numbers from that die? So if we get that probability, the probability of obtaining odd numbers will be 1 minus the probability of obtaining those even numbers. So if I say the probability of obtaining even numbers here was 1, and then the probability of obtaining odd numbers in this case will be what? 1 minus that probability of obtaining even numbers. So that becomes a binary class problem, obtaining even numbers or odd numbers. So most of the times we are looking for that positive class, which is what we define as what even numbers in that case. Like in the case of our spam detection problem, we are going to say if a message is spam, we are going to give it a 1. If it is non-spam, we are going to give it what? A 0. So that is how we are going to be labeling this kind of data when it comes to what? Binary classification problems. So what we have to note here is that this sigmoid function can only give values in what? In the range what? 0 and what? 1. So the decision rule for this sigmoid function is what? When we obtain any value which is greater than 0.5, we are predicting that what? That probability belongs to the positive class. So in that case, in the case of the spam dictation problem, it belongs to what? The spam class. And then if it is that sigmoid function is less than 0.5, and then we are going to be predicting that what? That email is what? Is non-spam, which is belonging to what? To class 0. So most of the times we use what we call the cost function, which is what? The log loss. This log loss is what we are going to be using mostly for classification-based problems. And one thing we have to note here is that for the regression problems, we are trying to minimize the mean squared error, which is the difference between that observed and the predicted value. The observed value, because we are looking at continuous values like the prices of houses, it will be a little bit different from a binary class problem. So for the binary class problem, what we are looking at, we are looking at the log loss, which is y raised to the power I. This I here will be like, because we have different input futures, we will also have belonging to what? To those two labels, 0 and what? And 1. Remember I said 1 is a spam message if it is that binary class problem, and then 0 is what? Is non-spam. So if we can obtain that probability of belonging to 1, which is that spam, we are going to have this first part of this function, and then 1 minus y of 1 will be the case of what? If it belongs to what? The 0 class label, which is what? Non-spam. So that is actually the mathematical concept of this cost function. So we are going to use this cost function to now what? To minimize to minimize this this sigmoid function. And then remember this sigmoid function, if we substitute z here, it will be having what? These parameters, and we can obtain these parameters, and from there we will be able to learn that decision boundary that can differentiate between what? Whether a message is spam or non-spam. So most of the time what we use to minimize this cost function is what we call gradient descent. Gradient descent is a technique that is being used to do what? To optimize that cost function to be able to obtain what? These parameters. So what we use most of the times to obtain these parameters is using differential calculus. Most of us have taken classes in differential calculus. We did this both in high school, but we didn't know how important it is in machine learning. I don't want to go deep into these mathematical concepts. For those of us that really want to study and see how we can differentiate this function to obtain these to be able to calculate these parameters, we can actually go deep into differentiating this cost function and see how we can obtain both this weight and the bias. Now, most of the times we have what we call the learning rate, which is actually what is being used to be able to see how is this cost function changing between those different inputs leading to to those outputs. So which is like we are trying to find that minimum value that we get to be able to predict whether an email is spam or non-spam. So when we build that model, how do we evaluate if that model is performing well? The first thing we have to note here, we have to note what is called a confusion matrix. A confusion matrix is used to summarize between the predictions and the actual values. What I mean here, the predictions is what actually when we obtain these parameters from that model and we are able to make these decisions, can we actually match those decisions with what the actual output from the model, from the actual data set? Remember, the predictions will be coming from the model, and these actual values will be what we had in the data set initially. Because what we are trying to do is to be able to automate this processing rather than allowing humans. When the data set becomes so large, humans might be able to make a lot of errors in trying to distinguish whether an email is spam or non-spam. So that is why most of the time we want to automate these processes. So the first thing we are going to be noting here on this confusion matrix, we have what we call what? The actual positive, actual negative, and then we also have what? The predicted positive and what? The predicted negative. The actual positive here is actually what we get from the initial data set, and then the predicted positive here is the predicted class, which is the spam class when we build our model. Same, the actual negative here is what is in the case of the known spam text, which we are giving it a 0. And then the predicted negative here is what our model was able to get from using what? The input futures compared to, and then use it to make these decisions whether a message is spam or not spam. So what we have to note here first is what we call what? True positive. The true positive here is actually the predicted positive, and also we have to note here this predicted positive is did the model actually get that positive class right? Now, another thing we have to note here is what we call what? The false negative. The false negative here is the model's predicted negative, but it was actually what? Positive. So we see here that this is actually belonging to the positive class, but the model is making a mistake and saying that it belongs to what? The negative class. That is what we call what? A false positive. Another thing we have to note here about what? A false, this is false negative. One thing we have to note again is what we call what? A false positive. False positive is the case when the model predicted that that message belongs to the positive class, but actually it belongs to what? To the negative class. And then the true positive is when the model says it belongs to the negative class when it actually belongs to what? The negative class. So a good example here is a model says an email is non-spam and it really isn't it. So when we get this confusion matrix, we can try to calculate what we start with, what the accuracy. We are going to see how these different matrices work, when to use them and when not to use them. So accuracy here is the overall correctness of the classifier, which we mean here classifier is actually that classification model, which looks at what? The true positive plus what? True negative divided by what? The total. Most of the time, if we are going to be having a classification-based problem where we have some balance between the spam and non-spam. What I mean here by balance is what? If we have spam, the spam classes to be 40% and non-spam to be like 60%, then we can use accuracy to evaluate that model. But when we will come into agglomerated dictation problems where we have them call them imbalanced class problem, where there is a great discrepancy between the negative and the positive classes. Maybe the negative classes, which is the non-spam, goes to like maybe 95%, and the spam class is like 5%. We might not be able to use accuracy in that kind of problem, because if we use accuracy, the model will, we will not be able to be making the right decisions, because the negative classes at 95% and the positive class is just at 5%. That model will always be saying that most of these messages belongs to what? To that negative class, which in that case accuracy will be a wrong metrics to use. Now we have what we call what? Precision. Precision is also called the positive predicted value, which is a fraction of relevant instances among the retrieved instances, which precision here is what? True positive divided by what? The true positive plus what? The false positive. Also, we have what we call recall. Recall is also called this sensitivity, which is a fraction of relevant instances that have been retrieved over what? The total amount of relevant instances. Also, we call what we call the F1 score, which is just the weighted average of what? Precision and recall. One thing we have to note here when we come to imbalanced class problem where we have the negative class to be like having 95%, and then the positive class to be just like 5% of the total class levels in our data set. We are going to be seeing how we can use what prefer, what precision, recall, and what the F1 score. Another technique that we are going to see more if we are going to be ranking is what we call what the receiver operating characteristic curve, which plots what the true positive rate versus what the false positive rate. We use this a lot if we are dealing with models that are capable of predicting probabilities correctly, which is something like the logistic regression, because we can actually adjust the ROC curves to adjust for what? To adjust for the true positive rate and what the false positive rate. So when we plot this, we can look at the area under that curve, which measures the quality of predictions across what? Those different thresholds. And these thresholds will be what I'm mentioning about what these probabilities or decisions we can get from that model. That was it for this basic lesson on logistic regression. So for our next lesson, we are going to be looking at lab 2, where we are going to grab a data set and then use that data set, to solve some real world problems. Keep following me for more of these tips, guys. As I did mention, you are going to find and see how you are adding skills to, in most of your field or in most of what you have learned, whether you are doing mathematics, whether you are doing electrical engineering, whether you are a business student, and so on. Thank you so much, guys. Keep following me more on Facebook, as well as subscribe to my YouTube channel to get notification every time I post my videos. Thank you so much.